Howdy. Today we're going to talk a little bit about compost. Granted, we did that for an hour or so last week. And then more importantly, not me, but Claire is going to show you how to make compost. Okay, let's talk about some of the rudimentary things. The pile. One of the nicknames for a compost pile is it's a microbial layer cake. You put together a set of circumstances and you just simply activate biology. Biology in this case is organisms, largely microorganisms, bacteria, fungi, and actinomycetes. And if you put together the right recipe in your microbial layer cake, you can just let it bake. The organisms will take over, and this is a classic example of harnessing biology to work on your behalf. I like how in Europe they don't call organic growers organic farmers, they call them biological farmers, and I think that's apt and appropriate. Okay, so let's talk a little bit about dimensions of a pile. And all you home gardeners, 5 letters, R-E-L-A-X, relax. Any size pile you build, any time interval to build it, anything you put in it, it's probably going to be all right, in fact, quite good. But I'm going to talk about ideals here. Conventional wisdom now says it's ideal to make a pile with a minimum volume of 5 feet by 5 feet by 5 feet. I don't quite agree. 5 feet, yeah, and even a little wider. We'll get to that in a minute. 5 feet, really, I'm not really wanting to catapult stuff up. I'm thinking 3.5, 4 is a good height. The length, what's the volume of materials you have? But so if you made a 3 by 3 by 3 foot pile, it would be fine. Or if you're a home gardener and you just make it incrementally in a bin, that's cool too. What's the idea behind this 5 by 5 by 5? It goes to a principle called volume to surface area. You want a very large internal volume and a minimal external surface area. As you can see here, the external layer of the pile, the surface area, is largely degraded by the environment. It doesn't compost well. What you want is a big internal combustion chamber, a good volume like that. There's another similar thing in terms of volume to surface area, and that's about the particle size of the materials that you use. During the demo, Claire will do some chopping. But what you want is an admixture of things that are a little bit coarse and rough, straw, sunflower stalks, things like that, and things that are fine and particulate, grass clippings, and things of that nature. So if you have too much rough, coarse stuff, you want to chop it up. And in chopping it up, you reduce the size of it, but you increase the surface area quite substantially. And on that increased surface area, plants are basically supported columns of water, about 80–90% water encased by cellulose. And when you chop up a plant, you open up the soft inner substrate, and it makes it easier for the microbes to get on it and decompose it. And again, as you chop it up, you increase the surface area, and so there can be more microbes. In general, more microbes is better than less microbes. So particle size, pile size, things to pay attention. When you make a pile initially, whatever its size, it's a good idea to lay down a footprint. You usually start at the bottom with a carbon layer, wood chips, leaves, straw, stuff like that. And it just says, this is where we're going. This is the size of the pile, and as we put each layer on, we try to keep it square or rectilinear, and you pay quite a bit of attention to detail. You want each layer to be absolutely tabletop flat and the sides to be straight, and so you have to fuss with it, pull, push, pat it down, fluff it up a little bit. And the reason for that is you want your pile to be like this. I love pyramids, they're great, but as you have a pile and it tapers substantially, you have, again, less internal volume. It's not as good of an area for composting. So straight size, flat top, thin repetitive layers. And you can take this to the nth degree. The thinner and more repetitive layers, the better the environment's going to be for decomposition. What's really best is to chop, shred, and totally homogenize everything that goes into a compost pile, but that's extremely laborious. So this idea of thin and repetitive layer, well, it's just a lazy person's way of approximating what I just said. So thin and repetitive layers. Okay, so starting point, the rectilinear microbial layer cake. And compost is a truly transformative process. And I mean that, yeah, metaphorically in a dreamy way like that, but I mean that literally and biochemically. We go from this to this. This is about a 9-month-old pile, but it was looking like this at about 3 or 4 months. What have we got here? Well, it's black gold, folks. It's the richest commodity on the planet, arguably, but you wouldn't get an argument from me. So this is where we start. This is where we're going. Let's go down here and look at some of the ingredients that are going to help us lay down this microbial layer cake. Okay, here's the gallery. We have, as usual, rounded up the usual suspects for making compost. And when you make compost, you can pose the question, what do you make compost out of? The answer is whatever you can get that's available, free or cheap. Free stuff is good. And you usually have an admixture, a blend of things that are nitrogenous, lush, and greens, such as lush greens, and in this case in the background, a pile of horse manure in wood chips as bedding material. So you use a combination of nitrogenous things, and down the line here we have straw, leaves, and wood chips, and these are carbon-based things. And your ratios can be variable. You could literally use 1/2 by volume, 1/2 nitrogenous material, lush green things and manure, 1/2 carbon material. If you want a pile to activate quicker and finish quicker, you would slant your ratio more towards nitrogen products. And that will break down, heat up higher, break down quicker, and probably in the end give you a compost pile that is more nutrient laden. If you do the opposite, whereas you emphasize carbon-based materials, straw, leaves, wood chips being good examples, the pile won't get as hot. It'll take longer, considerably longer to break down. But in the end, you'll probably have you'll have nutrients, don't worry. But you'll have a higher organic matter content, and that in turn will build the organic matter content of your soil. Okay, let's just look at some of the specifics here. I have a range of greens here, and the way these succulent greens work in a compost pile, it's like a hot knife through butter. It just dissolves. These things will literally not be recognizable within 3 to 5 days of constructing the compost pile. This is nasturtium largely, which is the essence of succulents. This is a powerful herb called comfrey, which is extremely nitrogen rich. And here I have something that's a little bit of a tweener. It's dahlia stems that are still green, but you can see there's also a little structural rigidity. That's carbon. So, and here Claire just harvested some fresh wild mustard, and then I was poking around in the garden, and look what I found. I found a volunteer daikon radish. And let me diverge a little from the topic and go back to cover crops, which just say daikon radishes are now used in cover cropping schemes, and they call them biodrills. They have some that there's one variety that Territorial Seeds and Johnny Seeds both have called groundhog daikon, and it just sends a tap root like this down 2 feet and opens up and fractures the soil. Anyhow, nitrogen and hey, I'm not afraid. Every home gardener's nightmare, Guigapi kitchen scraps, real high in nitrogen. If we look on the scale, you'll see reference in books, carbon to the nitrogen ratios, and in the green, lush, nitrogenous end of things like lawn clippings and these extremely green things I just showed you are probably somewhere in the 15, maybe as low as 10-to-1 CN ratio. Kitchen scraps would probably be 6 to 10-to-1, extremely nitrogenous. Again, nitrogen activates a compost pile. We'll go over, why these ratios in a minute. Moving on down the line, so you have your greens and your browns. Your browns could be things like this old spoiled straw, not hay. Hay has seeds. You do not want to seed grass seeds into your compost pile. Leaves from deciduous trees. They're beautiful. And then these two products are probably whereas our greens and nitrogen based stuff was in the teens to 1, 20-to-1 ratio. The straw and the leaves are probably about 40 to 50 to 1 CN ratio. That means way more carbon. And then last, but certainly not least, wood chips. Wood chips are about 400 to 500 to 1. Extremely carbonaceous and extremely long and slow in its breakdown. And my bad, I forgot one of our main ingredients here with the nitrogen-rich products. Yeah, I can say it. Horse shit. Horse manure or any type of animal manure you can get. And you don't have to use manures, but one of the advantages of using manures in a compost pile is that they are so microbially rich. They just activate the pile like that. And a manure is not a manure is not a manure. Some manures have more nutrients than others. Chicken or bird manure is the highest nitrogen and phosphorus containing a manure. Good way to load up on those two nutrients. Horse manure is not particularly high in nitrogen, but there's something about it, especially if it's, in this case, as you see in this case, it's got a bedding substrate. It could be straw, it could be wood chips, it could be wood shavings. There's probably nothing better in the world that will build the body of your soil or its organic matter and structure than composted horse manure. So you put these things together, as I said, in thin, repetitive layers. Let's say we're going to just do a 50-50 blend of nitrogenous or carbonaceous and nitrogenous things. So you would start out, as I said, with a base, just to outline the footprint, maybe an inch or two of straw or an inch or two of wood chips. And then you start building on that. You generally alternate. If you have a carbon layer, then you have a nitrogen layer. You have a carbon layer, you have a nitrogen layer, and on and on. It's important that you water the pile incrementally as you go. You just wet each layer. Now, all these different ingredients have different existing water content, so you water them accordingly. But you put a little water on everything. On some of the carbon, you have to actually put a lot of water on to wet them and activate them. Nothing stops the decomposition process quicker than a dry situation. So water incrementally as you go, and do that. Don't make a pile and try to wet it because it's nigh on to impossible to have it penetrate evenly throughout. So we have these ingredients, we move down the line, and again we finish with this, black gold. To me, I understand the processes biochemically and physically, and yet it's astonishing, it's magic, it's transformative. Make compost.
Hi, I'm Clare Riesman, Assistant Manager at the Chadwick Garden, and I'm going to walk you through the steps of making a compost pile. So to start out with, we'll clear a space, and then we'll lay down a footprint of wood chips in that space, both to delineate where our pile will be and also to absorb the moisture that we'll be adding throughout the process. We're going to be adding a lot of water to keep the process moving, and we don't want all that water to run off, and so the wood chips will absorb it at the bottom. Then we're going to start adding our layers. The layers we'll be working with today are manure, greens, which is just fresh leaves and such from the garden, and browns, which will be leaves, wood chips, and straw. The layering sequence is not too specific, but what I want to try to do is wherever we have very airy material, like straw, where there's just a lot of air and it's not very dense, we'll add something like manure or plants with soil attached to them so that those pieces can start to drop through and mix together. At each sequence, I'm going to be adding some water, especially for the drier materials. I want to add water to accelerate the decomposition process. As I go along, I'm also going to be paying attention to minding the corners and edges of my pile, and so that means the tendency without paying attention to it is for the stack of the compost pile to turn into a rounded sort of shape, and we really want to keep it in that boxy sort of shape to maximize internal area to surface area. The more surface area you have, the less active those spaces are, and so we want to consolidate the heat and keep it contained and really maximize the spaces for decomposition. And then once I'm done, I'm gonna finish it off with a straw cap. So I'll get some nice unbroken down straw and sprinkle it on top as a way of sealing not completely sealing, but really covering up the pile so it can continue to decompose. That's how you build a compost pile, and to be clear, this is the way we build a compost pile here. This is the system that works for us, given the materials and the space and the labor power we have. But you can make a compost pile of any sort of size depending on what materials you have and what your space looks like. So this is the way we build a compost pile, and happy compost building.